There was a random survey done, and here is the data that we got. If you look at the table, it gives you the number of people in different age groups. Look at the table carefully. Do you see something peculiar? Yes, the class intervals. They are not uniform. 0 to 5, 5 to 10, fine, but 10 to 20. So they are not uniform. But the class interval is continuous. Fine. So what we need to do is, we need some parameter which will have the same effect as a class size that is uniform. How do we do that? Well, that parameter is called adjusted frequency of a class. And this is how we calculate it. Minimum class size divided by class size into frequency. Once you've done that, drawing the histogram will be easy. Fine. Let's now look at the table again. In the first column, you have age. Second column, you have frequency. That is the number of people. This is already given to you. Let me make another column which gives the class size. 5, 5, 10, 20, 10, 30. You see this non-uniform class size? Now let me add the critical column, adjusted frequency. Get back to the formula. For the first row, 0 to 5 age group, the adjusted frequency is minimum class size, which is 5, divided by the class size. In this case, that is also 5. So 5 by 5 into frequency, which is 7. So we get our adjusted frequency as 7. Second row, minimum class size 5, this class size 5, frequency 9, and we get our adjusted frequency once again as 9. The third one, carefully, minimum class size, well, that will remain the same, 5. And this class size, this time it is 10 to 20, so it is 10 into, what is the frequency? 14. So we get the adjusted frequency as 7. Similarly, we do it for the rest of the rows. And we've got our complete column of adjusted frequency. Now we are ready to draw the histogram. What is the first step? We draw two mutually perpendicular axes. Now the intersection is obviously the origin. The horizontal axis is x-axis, which could represent age, and the vertical axis, the y-axis, that gives the number of people. Now we need to choose a suitable scale. Let me take the scale on the x-axis as 1 centimeter equals 10 years. Fine? You can take a different scale, but I guess this is more convenient. On y-axis, we say 1 centimeter is equal to 1 person. Now what do? The next step. We construct rectangular bar graphs by taking the given class interval as width of the rectangular bar. Fine? That was given in the original data. And we take the adjusted frequency as the length of the rectangular bar. That is the height in this case. Fine? Look at it carefully. This is your histogram. Observe it. For each of the rectangles, notice the width is the original class interval and the height is the adjusted frequency. Now it's a correct and beautiful histogram.